Pretty funny, dude. All right, so we just went through an example like this on page 294. Now is the part where I should be able to kind of get this on my own. Okay? We want to know which rectangle is similar to this one, RSTU. This is going to be our original shape. Wait a minute, what does similar mean again? If they're similar, what do we know about those two shapes? They are?
The same.
They are not the same. No, they are what? They are proportional. Very different. Proportional means they change by the same amount, but they do not have to be the same size. They're either going to get bigger or smaller by the same scale factor. So all of our words are starting to mesh together. So if you don't know the definitions from one day to the next, today gets a little hard. Okay, make sure you're putting them in your brain. And so again, just like in the book, I'm always going to put my original over this matching one to see if it works. And I probably could have picked a different word than match. We're going to see if it matches up or not, if it's proportional, if it's similar to it. And so, which side matches up, corresponds to RU in this shape? Which side corresponds to RU in this shape, Felisa? EH, that's right. And so I'm going to put the 3 on the top and the 6 on the bottom because I'm always going to put the original over the matching. And those two sides correspond to each other. They're both the short side on the rectangles. But proportional requires 2 fractions. So Stephanie, what other 2 side lengths correspond to each other on these 2 shapes? HG corresponds to what on our original shape? That's perfect. Now which one's going to go on the top and which one's going to go on the bottom, Steph? Why? Good. The original one's going to be on the top. Could I do it the other way and still get the right answer? Yeah. Yes, but you have to be consistent. Every time you do things proportionally, that's why I always start with labels. Now, are those 2 things equivalent?
Yeah.
How do you know? Felisa? They both reduce to 1/2. And so the answer is yes, they are proportional. So what do we know about these 2 shapes? They are not equal. They are similar. Similar. And the question is which ones are similar? That's how we know. We show that they are proportional, meaning we set up a proportion. If they're equal, and both of these equal 1/2, then we know they're similar.
Well, do we have to do all of them?
We're going to do all of them because I'm not convinced we can do this well yet. Absolutely. Question?
How do we know what the corresponding side is?
This one's all kinds of wonky, isn't it? It's a little bit different. It has to be the same relative one, which means the short side has to correspond to the short side. And the long side has to correspond to the long side. So when I'm setting this up, which side on this shape, MNPQ, corresponds to RU? Which side on this shape corresponds to RU and why? That's the part I'm most interested in. What do you think, Jessalyn? Can you talk way louder because the blower's going really loud? So I'm asking about which side corresponds to RU on the original one. Is it this one or this one? It is QP. Tell me why it's QP. Yes. So I'm going to put the 3 on top of the 2 because the 3 is my original and 2 is my matching one. So this might be M1 and this one's M2. So you always have to match up short side to short side and long side to long side. Always. That's what corresponding means. That when I orient it the same way, it would match up. Steph, what's your question?
Do they have to like go with each other?
So we're going to see if the 2 ratios are equivalent. So we're not dividing right now. We're going to set up 2 ratios, 2 fractions, and see if they're equivalent or not. So we need 2 more corresponding sides. Which other 2 sides correspond to each other? Which ones? Can you give me some numbers? I'll pick this one, 5. Which one corresponds to 5 over here? There is no 5 on this shape.
Oh, I think that's
Nope. 5 and which one? 5 and 8 correspond. Why? Good. They're both the long sides. Which one goes on the top, the 5 or the 8? Which one goes on the top, the 5 or the 8? The 5, why? It totally matters. Why does the 5 go on top, Clayton? It's the original, and we've been putting the original on the top, so it does totally matter. I have 5 over 8. Are those two ratios equivalent to each other?
No.
No way. This one's over 1. That one's less than 1. Not equivalent. Is this shape similar to this one?
No.
No, not similar.
No.
I would like to do this one together.
Mrs. Smith,
Hmm.
you put non-proportional?
I put not similar because the question is which is similar, and so I'm answering the question. Now we're going to look at ABCD. Is this one even the same kind of shape? This is a rectangle. What's this shape? It's a square. Are they the same shape? So you automatically could say either not the same shape, not similar, because they have to look the same. But I also want to prove to you mathematically that they're also not similar based on the math numbers. 3 corresponds to, does it matter which 5 I pick?
No.
It doesn't. 3/5 does not equal 5 over 5. Also not similar. I will tell you, lots of 7th graders, when I tell them they have to be the same shape, they're just like, oh yeah, those ones look the same. Oh yeah, those ones don't look the same at all, but they don't have any math to prove it, and sometimes they're wrong because they in the book sometimes make them pretty close. Okay? I want you and your table mates to do number 2 together. So this is my original. Which triangle is similar to that one? What does similar mean? That's a perfect spot for it. Thank you. Similar means what? You have to show that they are not alike. They proportional. They are not the same size. They are proportional. Go.